Hi everyone, my name is Prateek Kumar. Today I will discuss the topic called nog maps, in which I will discuss the minimum forms of switching functions. We are realizing any function using AND gates and OR gates. The cost of realize depend upon the number of gates we are using and the number of inputs we use. And we are going to see in this topic K-map. The K-map is used to simplify the digital circuits. By using that, we can minimize the function. For this, we use two methods to minimize the function. First, SOP and then POS, which is sum of products and the product of sum. Before going in depth in SOP and POS, first we will see the basics of these. If a number of input variable are n, then the total number of combinations in the Boolean algebra is 2 to the power n. What it means? If the input is let us suppose a function is given a, b, c, in which input is n equals to 3, then the total number of combination possible is 2 to the power n. So we get 2 to the power 3, which is 8. So we have 8 numbers of combinations we can get from 3 inputs. We can also go for 4. If a, b, c, d, then n equals to 4 and 2 to the power 4, we get 16 combinations. So if the input variable, let a, value is 0, so we can also say that a is low, and it should be represented as a dash or complement of a, or we also say that a bar. If it is 1, a is high, it should be represented as a. In Boolean logic, and is represented as dot product, and a and b is written as a dot b, or is represented at plus sign, and a or b is written as a plus b. Let us see some of the examples, then we will let about the SOP. Now let us see the topic SOP, which means sum of products. Before going in depth of SOP, first we will see that it is in this two operations are to be performed, OR operations and AND operation. And we will see also the minimum terms and the maximum terms. By using a circuit diagram, we will see the SOP. We will use AND gates, and then we will use OR gate. The input is A and B and B bar and A. So AND operation, we know that AND is denoted by A dot B. So B bar dot A. And for OR operation, we see that in the previous slide that it is represented by addition. So A dot B add addition B bar dot A. So in this we see that A dot B plus B bar dot A, this is sum of product, sum of products. Now after seeing that, we can let us see some of the example in SOP. So we have a function in which we have 3 inputs. So n is 3. So 2 to the power of n as we saw. So the total combination is 8 number of combination, 8 number of combination, and it is given by the in the question it is given that the minimum terms. So we have 0, 1, 2, 5, 6 and 7. So first write the 8 terms. So in binary form we will write, so it is in the trick is that 8 4 2 1, 8 4 2 1. So we have 3 inputs, so we will use 4 2 1. So for 0 0 0 0, for 1 it should be 0 0 1, for 2 it should be 0 1 0, for 3 it should be 0 1 1, for 4 it should be 1 0 0, for 4 it should be 1 0 0, for 5 it should be 1 0 1. For 6 it should be 1 1 0. 7 1 1 1. So it is represented at M0, M1, M2, M3, M4, M5, M6 and M7. In this question given that it should be 0, 1, 2, 5, 6 and 7. So we have 0, 1, 2, 5, 6 and 7. So we will write the function according to this. For M0 we have 0 0 0, and in the previous slide we see that 0 is represented as a complement and a bar, and 1 is represented as a. So this is a b c. Now we represent this as a bar, b bar, c bar. For M1 we represent 0 0 1, so a bar, b bar, c. For M2 0 1 0, a bar, b, c bar. For M5 we have 1 0 1, so a, b bar, c. For M6 we have 1 1 0, so a, b, c bar. And M7 we have 1 1 1, which means a, b, c. Now we have the function in the terms of the given expression. So we can write y is equals to a bar, b bar, c bar plus a bar, b bar, c plus a bar, b, c bar, then a, b bar, c plus a, b, c bar, then a, b, c. Now our task is to minimize this function. Okay, now let us see. We can write, after seeing these two expression, we can take common as a bar, b bar, then c bar plus c. Then we see that here b bar, c bar and b bar, c bar is common, b, c bar is common, so we can write a bar plus a, and in last we can take ac and b bar plus b. So one thing I want to teach you that c bar plus c or a bar plus a and b bar plus b, it should 1. Why it is 1? Because if we take c as a 1, then c bar is 0. So 0 plus 1 plus is, or so 0 or 1 is always 1. Okay, so it should be 1. So we have a bar, b bar plus b, c bar, then ac. This is the minimum expression for SOP. Now using this we can also make a gate for this using this. Now we have y is equals to, in the previous slide we see that the expression y is equals to a bar, b bar plus b, c bar, then ac bar. By using this we can draw the circuit diagram. Let us see the circuit diagram. For this we will make one NOT gate. For a bar we have 3 inputs, so we will make, this is b bar, then this is c, and this is c bar. So this is a, this is a bar, this is b, this is b bar, c and c bar. Now first see, this is a bar and b bar, and this is what, dot. So we use AND gate. So a bar and b bar, then we use AND gate to produce the output a bar dot b bar. Now then see b dot c bar. So similarly b and c bar, then AND gate, so the output is bc bar. Now at last we have a, c, so A and C using AND gate AC. Now these all expression are connected with a OR gate. So we will use OR gate here. All three are combined with the OR gate. So OR gate is this. Now the expression is what? A bar dot B bar plus BC bar plus AC. Now let us see the second, which is second method to minimize a function, which is POS, product of sum. In this we will use two operations for perform POS, which is AND operation and OR operation. As the name suggested, it is formed by the multiplying AND operation, the sum terms. These sum terms are also called as a max terms, and it is represented by M. They are the sums of Boolean variable either in normal forms or complemented forms. Therefore, the POS is a product of max terms, as is represented as F in POS is pi of max term 1 comma 2. Here F is a product of max term 1 and max term 2. For example, let us take an example. If A equals to 0, B equals to 1 and C equals to 0, then max terms can be written as A plus B complement B bar plus C. And if A equals to 1, B equals to 1, C equals to 1, then max term can be represented as A bar plus B bar plus C bar. These are the basics in the POS we will see. Now let us see the expression how to minimize this function. This is the function in the POS, product of sum. We have to deal with that. So F, we have to minimize it. By saying this, we will take a common factor, common. So in first two expression we will see that A plus B bar plus C plus D bar, and here what we have, A plus B bar plus C bar and D bar. So we will see that B bar and D bar is common. So by taking this A plus B bar plus D bar, then we have C plus C bar. Then in this we don't have any common factor. And then next, so we have A, C and D. So we will write A plus C bar plus D and B bar plus B as a common. Now in the last operation, last we will see that A bar plus C bar plus D and B bar plus B. We know that C plus C bar, B plus B bar and A plus A bar all are 1. So these terms are going to 1. So the function is A plus B bar plus D bar, A bar plus C bar plus D and A bar plus C bar plus D. Now once again we will see that if the function is going to minimize or not. So if we see that here A, B bar and D bar, and here A bar and no common factor. So we will see that here these two are the, we can say that the product of sum. Here product and these are the sum terms. So we can say that this is the product of sum. By giving the example, it will clear your doubts.